guys, welcome to my first webinar with Intech Instruments. I'm Craig Bennett, your host for this afternoon. If you have any questions, please text them in. I've got them all on mute so no one can interrupt, so I can go through the information and share it with you all. Just know that our latest info is on the website, especially probe codes. Okay, so if you do need to make a special probe, the latest information is on our website. The webinar will be available on a download from our website after the presentation. We'll get this underway. So here we have our temperature sensors, identification and selection. We'll talk about the two main temperature sensors used in the industry that we mostly sell, and that's the RTD and thermocouples. We'll not cover PTCs or NTC probes. They're too various and typically bespoke to a manufacturer and too hard to find or mimic. So which one to use, RTD or thermocouple? Factors you need to think about the temperature range you want to use it for, the response time, the size and shape, and the overall accuracy requirements. Looking at the RTD first, they're available in sizes down to 0.9 to 1.5 millimeters diameter, with a 15 millimeter length for miniature ceramics. And for a standard ceramic is about 3 by 15 millimeters. Flat film chips, which are the most common, are about a 2 by 2.3 millimeter size. As you can see, it's basically a platinum element wound around an insulated ceramic base, and it reacts by the change of resistance when exposed to temperature, and it's linear in its behavior. More people in. So the main types of RTD are the PT100 or the PT1000. We can get some rarer ones like a PT500 or copper and nickel variations like the copper 500 or nickel 1000 for special applications. The PT100 can be wired with 2-wire, 3-wire or 4-wire variable PTFE lead lengths for varying stem lengths to allow for lead compensation and accuracy. As you can see, PT stands for platinum, hence its wire around the element. You will see some of the advantages for RTDs. They're simple in construction, they're stable, repeatable, accurate to 0.1 of a degree, works well in temperature, ranges of negative 200 to 400 degrees. Limitations, they can be a bit fragile, maybe a slightly slower response time, and they need to be in a protective sheath. Accuracy classes, there are quite a few, but we tend to stock the Class A and Band 5. We can get Class B, but Class A is standard. As you can see, the different accuracies, the different types of sensors in this table. You can see that Class B is plus or minus 0.12%, which is potentially 0.3 degrees at 0 degrees. Class A's are plus or minus 0.06%, which works out to about 0.15 degrees at 0 degrees. Band 5 is the best you can get for an RTD or any probe that matter at plus or minus 0.01 degrees. 0.01%, which is 0.03 degrees at 0 degrees. Now we'll move on to thermocouples. Depending on the metals used, changes the temperature behaviors, temperature ranges, and accuracy, and we'll elaborate on those later. But as you can see, it's basically two different particular metals when junctioned together exposed to heat generate a millivolt reading that is linear in behaviour in relation to the heat it is exposed to. You can see here we have many sheath options available, and here are the common configurations. Obviously sealed sheath, sealed and isolated from the sheath, sealed and grounded to the sheath, and we have an exposed fast response tip or exposed bead tip. As you see, inside the sheath or an exposed bead with no sheath are standard in-stock items. Sheaths can be stainless steel, Inconel, Nicrobel, and ceramic. In some special situations, there can be no sheath and just ceramic spaces keep the metals apart to the junction at the tip. Here we have some of the advantages of a thermocouple. They can do higher temperature ranges, they can be cheaper, they're more durable, and they have a fast response time. Limitations are they're not quite as accurate, and there's less stability in the reading because it can jump around a bit, and it requires different types for different temperature ranges. You see on the grades, it's important that there are two types of grades to be aware of, thermocouple grade and extension grade. And these indicate the purity of the metal and therefore the difference between being able to use the metal pair to create a junction or to do longer runs to carry the millivolt reading over a distance for a cheaper cost. Thermocouples are differentiated by letters representing the type of metals used and the temperature ranges they handle, and accurately in a linear fashion. With our probes, we commonly do K-type, J-type, T-type, and on occasions for special industries, E, R, and N-type. Very rare ones you can see are the C, D, U, G, L, M, V, and P. Here we have the colour codings. You can see it's important to colour code thermocouples to be able to tell them apart. From country to country, there may be variations. They can have their own colour codes that may conflict with typical standards, but this table is an indicator of the common conventions. Here you can see type K can do up to 1372 degrees, but typically it's used up to 1200 degrees and is limited by the Nicrobel metal it could potentially be sheathed in. A J type can do quite high, but typically is not used over 400 degrees due to this fiberglass sheathing that may limit its range. T type is typically used up to 200 degrees and comes in a Teflon coating that we stock. R type is the highest temperature probe we can stock, and it's rated to 1600 degrees and is usually housed in a ceramic sheath in common applications. It is made with a very expensive, rare and sensitive metal and is not recommended to touch it with bare hands as it can affect its purity and contaminate it, affecting accuracy and longevity. Here you see the comparison between the two temperature conventions of RTDs and thermocouples, and we see the pros and cons. Obviously, the RTDs are more accurate, and the temperature ranges, it can't quite go as high as the thermocouples, which can achieve up to 2000 degrees for some models. Costs, obviously, the RTDs are slightly more expensive, and thermocouple is cheaper. Sensitivity, and also response times. Obviously, the RTD, that's one of its, even though it has the accuracy, it has a slightly slower response time, and as you can see, it's between 1 and 7 seconds. And thermocouples are virtually instantaneous, being less than a second. RTDs are robust. I think thermocouples are probably even more. Long-term stability, excellent and good in thermocouples, but they can be subject to drift. And as you can see, the outputs are different with RTDs. It's to do with the resistance, and with the thermocouples it's to do with the millivolt generated between the two dissimilar metals coming together. And RTDs are less susceptible to electrical noise, and thermocouples are more. Here we introduce some of the different form factors that temperature probes can come in, and the important things to specify when you're wanting a probe. Here we have the most common types: a probe with a head, process connection thread, and a stem. And below it is a probe with a stem and lead. Most important to specify is the stem diameter and length, and the lead length if it needs it. Other factors that can be added to these options can be pot seals between the lead and stem to allow for better seal against moisture ingress, or the ability to have smaller stems. With thermocouples, we can potentially go down to 1 mm stems. Other factors that can be added to these options can, threads partway down the stem or running nuts, triclover or RJT with a big castellated nut, typically used in dairy applications with a highly polished finish for hygiene. Other things to consider with temperature probe selection, obviously fast response tips. Standard means it's simplex, is just has a single sensor in the end, in the tip, and duplex, where you can have a double sensor in the tip. Other things to consider, we have different head types, small or large aluminium, polypropylene, bakelite, stainless steel, and obviously the typically stock the 1/2" thread, but we can do other threads on request. More on this are the options for a transmitter to be mounted in the head or remotely on a DIN rail. Transmitters can be isolated or non-isolated, or if you require EX rating or heart programmability. Terminal block options, you can see fixed, floating, ceramic, or bakelite. Obviously ceramic for the hotter temperatures. And obviously if the probe has a lead, then you may need a plug. And we stock most common thermocouple plugs. You can get plugs for RTDs as well if requested. More accessories available at Intech. Here are the most common ones stocked. The P1 pocket, as you can see in the image here, has a 1/2" BSP taper external thread and a 1/4" taper internal. The P2 pocket has a 1/2" BSP taper external thread and a 1/2" taper internal. Now these come in variable lengths, starting at 70 mm length and to go up in 50 mm increments. Flanges are available, and they can suit your stem diameter and glands as well. As you can see, we have the S1 gland with a 1/4 BSP taper suited to a 6.4 millimeter diameter stem, which is a 1/4", and the S2 gland with a 1/2" BSP taper thread, and it also suits a 6.4 or 1/4" stem. If you need a bespoke solution, we can also accommodate that if you can specify the dimensions you need to work with. Here are a few of the form factors that are common and stocked at Intech. You can see the MTC, handheld HHTs, UTKs or UTJs, typically used in the plastics industry, ROSIL, which is a common probe with silicon lead. We have wall-mounted aluminium RTDs. We have our most common RHP and MTHP probes with process connections, and typically just RH or MTH if it had no thread. And we have our sanitary probes, which can have a running nuts, triclovers, and RJT with castellated nuts. We can also make any bespoke original probes to suit your application. Just chat to us and we can draw it up and give you a quote. On the website, you can download a copy of the current probe catalogue or a copy of our latest 2020 catalogue with prices on the stock models. A new probe catalogue will be available this year to reflect the new website and the new probe code, so watch out for it in the coming months. Well, that's the end of the presentation for now. Thanks for listening in. I'll now answer any questions if you have, if you sent them in during the presentation, or just flick them through an email to me and I can answer them direct to you later. Thank you once again for coming along to the webinar and sitting in. Have a great day, and we'll see you next time we broadcast our next webinar in the near future. If you have any queries, don't hesitate to contact us through our website or email us at sales@intech.co.nz or call us at 03 343 0646. Thanks very much, guys. Cheers.